Hi guys, this is 7-3 for Friday, February 24th. The homework is to do the example number 3 on the next page. We're going to do these first two examples. So differential equations, example number 1. So we've got y prime equals xy if y equals 700 when x equals 4. This is called the initial condition. Initial condition. All right, this is a differential equation. Okay, so that's a differential equation because it's an equation with a derivative involved. So differential equation, we have an initial condition, and then they're saying to us find y when x equals 5.2. So if we could find the solution to this, if we could find the particular solution to this differential equation, then we could figure this out. All right, so we're going to find the particular solution given this information, and then we'll figure out what they're asking. So first we'll find the general solution. So I convert to Leibniz notation. Okay, to convert to Leibniz notation, then dy equals xy dx. Okay, I've got to separate the x's and y's, so this is 1 over y dy equals x dx. All right, and then you take the indefinite integral of both sides, which is the same thing as the antiderivative. So natural log of absolute value of y equals 1/2 x squared plus c. That is the general solution. Okay, so general solution right here with the plus c. Okay, so we'll say general solution for our notes. To find the particular solution, we'll use this initial condition. So I'm going to rewrite the general solution, leaving a blank where I had x's and y's. What goes in where y used to be 700? What goes in where x used to be 4? So you get the natural log of 700. I don't need the absolute values because 700 is already positive. And then this is 8 plus c. Right? Yep. So c equals natural log of 700 minus 8. Oopsie. So my particular solution is the natural log of the absolute value of y equals 1/2 x squared plus c was natural log of 700 minus 8. Okay, so this is the particular solution. Now, for this particular solution, we're going to plug in 5.2 for x and figure out what y is when x is 5.2. All right, so this is the natural log of the absolute value of y equals 1/2 x squared. Wait, this is 5.2 squared plus natural log of 700 minus 8. So this is the natural log of the absolute value of y, and that is equal to 5.52. This is what I got when I combined like terms. 5.52 plus the natural log of 700. Now we have to solve for y, okay? And we will practice these more. But the way that you solve for y in a situation, if y is you could like roll up the log. I know a lot of you think say that, or you could raise. What would this be? This would be e to the that equals the absolute value. Yeah, okay, that's good. Yeah, so I'm going to take this, I'm going to convert from logarithmic form to exponential form. So this is log base e of the absolute value of y. So I can say e to the this power equals the absolute value of y. So I'm converting from logarithmic to exponential form. So I say that the absolute value of y is equal to e to this power right here, to the 5.52 plus the natural log of 700 100. Okay. And I could simplify this a little bit, but I won't just yet. Okay, now the absolute value of y equals that, so that means that y could be the positive or the negative value of this. Because if it's in the absolute values, it could be positive or negative, and we would still have the same output in the end. Okay, guys, so there's that. So y could be one of two values when x is 5.2. Okay, now we are not done because we have example number 2. All right, for the differential equation given right here, verify that this is a solution of the differential equation. So, guys, the way that you do this is like the same way. Like if you wanted to verify that a point was on a line algebraically, you would plug the x and y coordinates into the, in for x and y and see if everything works out. We're going to do something kind of similar. So I'm going to, wherever I see dy dx, well, I got to get the derivative of this, and then I'll plug that in where I see dy dx, and then I'll plug y in where I see y. All right, so for number 1, we've got that y is equal to x to the third plus 3. And then I do y prime equals 3x squared, okay? Now I'm going to take the differential equation. I'll bring down the x. I'll leave a blank where dy dx is, plus 9 equals 3. I'll leave a blank where y is. Now, what was here before was dy dx. Another name for that is y prime. These are the same thing. I was just using different notation down here. So 3x squared goes in for that. And then what used to be here was y. So I plug x to the third plus 3 in there. This is 3x to the third plus 9 equals 3x to the third plus 9. Okay, those would cancel. And then you end up with 9 equals 9. Okay, so if you end up with what's called a tautology, just something equals itself, it's always true under any circumstances. That means that this equation is a solution to that differential equation. All right, let's do it again for number 2. We've got y is equal to 5x to the third plus 3. Y prime is equal to 15x squared. And then I'll take the differential equation. I'll leave blanks where I had dy dx and where I had y. What goes in for dy dx is the derivative, so 15x squared. What goes in for y is the original equation that we were given. And then I get that 15x cubed plus 9 equals 15x cubed plus 9. Those would cancel. 9 equals 9 again, check. Okay, so both of those are solutions. Now number 3, we're going to show that it's not a solution. All right, and really I should probably be explaining why at the end, but we'll work on that at another time. So we're going to show that this one is not a solution. So we're going to do the same thing, and if we end up with a contradiction instead of a tautology, then we will have shown it. So y is equal to x to the third plus 10. Y prime is 3x squared. X blank plus 9 equals 3 times blank. What goes in for dy dx is the derivative. What goes in for y is y. 3x to the third plus 9 equals 3x to the third plus 30. Those would cancel, and we would end up with 9 equals 30, which is a contradiction. Okay, if you have something that leads to a contradiction, it means that the original thing had to be false to begin with. Okay, so that is not a solution. All right, guys, so there is that. Yeah, and I will see you soon. Remember that the homework is number 3 on the next page. Okay, bye-bye.